This lesson is about taking a word problem and converting it into the mathematical inequalities and equations necessary, as in writing the constraints. So we want to take the word problem and change it so that we have both the constraints and the optimizing function. The other video shows what to do with the constraints and the optimizing function using the steps on the formula sheet. So we got two examples we'll take a look at. In this one, read through the word problem. Don't get too bogged down in details, but look especially at the question at the end of the problem. Step number one, we want to make sure that we make a connection between what we're looking for and the mathematical variables that we're going to be using. Your book loves to use like x sub 1 and x sub 2 and so on instead of x and y and z or a and b and c. It's not really going to be important what variables you use as long as you're consistent. I'm talking about on your test. Now in the problems in my math lab are going to require you to use x1s, x2s, and x3s. So let's see about this one. Look at the question at the very end. We see how much should be invested in each type of investment. So that's what we're looking for, the amount invested in each type of investment. Well, let's look back up at the problem and see what sort of investments are there. There's government bonds, mutual funds, and money market funds. So we want to choose three variables to represent those three things. Technically, the order doesn't matter. You'll find that throughout these problems, if you will maintain the order as they're stated in the very beginning of the problem, it will be consistent throughout the problem. And so we will take x1 to be the amount invested in government bonds, x2 the amount invested in mutual funds, and x3 the amount invested in money market funds. So that's step one. Make sure you write down the variables. Don't just try keeping track of them in your head. It's not going to work. Next, we want to write the constraints. Now this involves reading through the problem and looking for key words that tell us something is a limitation. For example, you'll notice at the beginning in the first sentence it says the investor has at most $100,000. That implies that he does not have any more than that. That's a constraint. About midway down, you see that the policy is that the amount invested in mutual and money market funds not exceed. Those are the words we're looking for that imply limitations. Now we want to translate those into inequalities. So we want to look back at the problem and see, well, what does that say about it? Well, if the investor has at most $100,000 and we were calling x1 the amount invested in government bonds, x2 mutual funds, and x3 money market funds, then the three together, as in added together, cannot exceed $100,000. You notice also that there's a limitation that the total amount invested in mutual and money market funds together not exceed the amount invested in government bonds. Well, the constraint there would be that the two added together, x2 and x3, is no bigger than x1, since that's what we called those. We will modify the second inequality so it's in more of a standard format with all the variables on the left. That would make the x1 negative when we moved it over to the left. So there are the constraints. The optimizing function, when you look at the question at the end of the problem, how much should be invested to maximize the return? So we're trying to maximize the return. We need to come up with a function that represents the return, which which would be like the profit. And so look at what it says in the sentence, second sentence. The yield or return or profit is 8% on government bonds, 13% on mutual funds, and 15% on money market funds. And so we take 8% times the amount invested in government bonds, which in step 1 we called X1. 13% or 0.13 times the amount invested in mutual funds, which we called X2, and 0.15 times the amount invested in money market funds, which we called X3, all added together is our return or yield. So that would be our optimizing function. And so the problem would look like this with them all together. Here's our variables, here's our constraints, and our optimizing function. Now in the other video, I show you what to do with those. Let's look at one other example. And let's do this a little bit more streamlined. Step 1, how about our variables? Look at the question at the end. How many houses of each type? What are the types of houses? Back up in sentence 1. So X1 is the colonial, X2 the split level, and X3 the ranch. Constraints. Look for words in the problem that imply limitations. Next to the last sentence, the contractor has available, meaning no more than this much land, this much money, and this many hours. And so each of those three things would be a constraint. Let's look at the acres of land. It says in the second sentence, a colonial house requires a half acre of land. And so the number of colonial houses, X1, times 1/2, meaning the amount of land each one of them takes, is the total amount of land that the colonial houses would take. Similarly, the split level requires a half acre each, so 1/2 times X2 represents the total acres for split level. The ranch requires 1 acre each, so 1 times X3 is the total number of acres for the ranch. And that together cannot be more than 30 acres. On the money, says in the second sentence, colonial houses take 60,000, split level takes 60,000, and ranch takes 80,000. And so 60,000 X1, 60,000 X2, 80,000 X3 all together cannot be more than 3,200,000. Finally, the last constraint would be the labor hours. Again, looking through the problem at what is said about labor hours, second sentence says that the colonial house takes 4,000 labor hours. The ranch houses, the split level houses take 3,000 labor hours, and the ranch takes 4,000 labor hours. So added together, that can't be more than 180,000. The optimizing function is trying to maximize the profit. Let's look back at the problem and what does it say about the profit. Colonial house has a profit of 20,000, split level a profit of 18, and ranch a profit of 24. So similarly, that would be a 20,000 X1, 18,000 X2, and 24,000 X3. So there are our variables, constraints, and optimizing function. Now we're ready for putting those together into the simplex matrix